Example number 13. Prove the trigonometric identity cos A plus sine A all over cos A minus sine A to be equals to sec 2A plus tan 2A. How do we prove a trigonometric identity? So before you prove a trigonometric identity, you investigate the identity, isn't it? So if you see the left hand side of the equation, we have a fraction. The right hand side of the equation, there is no fraction, isn't it? There is no. So if there is no fraction, it means they have gotten rid of the denominator, isn't it? They have gotten rid of that. So it means for us to get rid of the denominator, we multiply the denominator with this conjugate to get rid of the denominator, isn't it? We multiply the denominator with this conjugate. So on the left hand side of the equation, to prove this identity, you start with the left hand side until you get the right. So the left hand side has a denominator, the right hand side does not have a denominator. So it means for us to get rid of the denominator, we must multiply the denominator with this conjugate, isn't it? Its conjugate is just to simply alter the sign between the middle, isn't it? So here we have cos A plus sine A over cos A minus sine A. So the conjugate in the denominator, you simply change the sign in the middle only. So the sign in the middle is negative, isn't it? So it means this conjugate is going to be cos A plus sine A. So if A is negative, the conjugate is positive, isn't it? So you have to do the same in the numerator to balance that expression. So cos A plus sine A over cos A plus sine A is like you are multiplying with 1, isn't it? Are you seeing that? So you've not added anything there. You are only introducing that concept to reciprocal. In case of you want to get rid of the denominator, you multiply with this conjugate, isn't it? So the conjugate is a difference of two squares, isn't it? The conjugate is a difference of two, meaning this one is equals to, in the numerator we have cos A plus sine A squared, because you multiply a factor by itself. This factor times itself you get, it is that factor squared, isn't it? So A numerator we have cos A plus sine A squared. The denominator we have a difference of two squared. Remember, if you have A minus B into A plus B, you are supposed to get A squared minus B. So you can see our A is cos A, and our B is sine A. So this one is A minus B, this one is A plus B. See there? So it means we are going to get A squared, that is cos squared A, then minus sine squared A. Are we together? So are you seeing you rationalize the numerator? So what is cos squared A minus sine squared A? The cosine double angle, isn't it? That is the cosine double. This is the cosine double angle, because if you have cos A plus A, that is cos A, if this side is positive, the other side is negative, minus sine A, sine A, and you get cos A times cos A is cos A squared minus sine A times S A is sine A squared. So it means that is a cosine double angle. Have you seen that? That is a cosine double angle. So in the numerator we have cos A plus sine A squared over the denominator we have cos 2, isn't it? So it means we expand the numerator. We expand the numerator because our right hand side of this equation does not have a square, meaning we get rid of the square in that numerator, isn't it? You can see the right hand side of the identity we are proving does not have a square. See there? So we have to get rid of this square in the numerator, isn't it? So that numerator is the first quadratic identity. So the first quadratic identity, if you have A plus B squared, that is simply A squared plus 2AB plus B squared, isn't it? So if you have cos A plus sine A squared like that, where there is A you put cos A, where there is small b you put sine A, isn't it? So it means this one is going to be cos squared A plus 2 cos A sine A plus sine squared. Are you seeing you've expanded that? So having expanded that, you now take it back to your equation. So we have this is cos squared A plus 2 cos A sine A plus sine squared A all over cos 2A. Then you ask yourself, what is this? You rearrange. Cos squared A plus sine squared A is what? The Pythagorean identity, isn't it? I told you in any trigonometric identity you are proving you always come across the Pythagorean identity in the last class. Can you remember? Meaning the Pythagorean identity will always be there somewhere. Are we together? So you have the Pythagorean, but it's not a must that has to be there when you are dealing with the factor formulas and product identities. It is not always there. Are we together? But all these other identities, you will always see the Pythagorean identity, either coming as a difference of two squares or just coming as itself the way it is. So we have here cos squared A plus sine squared A is equivalent to what? Is equivalent to 1, isn't it? It's equivalent to 1. So in the numerator we have 1 plus 2 cos A sine A. Remember cos A sine A is the same as 2 sine A cos A all over cos 2A. Then you ask yourself, what is 2 sine A cos A? That is a sine double angle, isn't it? Are you seeing that? That is a sine double. If you have sine 2A, sine 2A is sine A plus A. These things you would have mastered them now. So sine A plus A is sine A cos A, isn't it? Then if A is positive, the other side is also positive. Sine A cos. Are we together? So if you have sine A plus A, that is sine A cos A, then plus sine A cos. Because if it was sine A plus B, it was going to be sine A cos B. So where there is B, A is occupying, isn't it? Are you seeing that? So here you end up with the 2 sine A cos A. So 2 sine A cos A is a sine double angle, isn't it? So where there is 2 sine A cos A, you put the sine double angle. So the numerator we have 1 plus sine 2A. Everything is over cos 2A. Are we together? Because in the right hand side of our equation you can see there are double angles. Meaning in this problem we have to look for those double angles. Are you seeing how to prove an identity? You get rid of what is not there, like a square is not there, we get rid of it. Then you check on the right hand side there are double angles. Meaning we look for those double angles. Are we together? Is that okay? So now the denominator we are getting rid of it because the denominator is not here. So this is the common denominator. So it's like we have 1 over cos 2A then plus sine 2A over cos 2A, isn't it? Are we together? So what is 1 over cos 2A? 1 over cos 2A is the reciprocal of cos 2A, isn't it? The reciprocal of cos is what? Sec. Meaning 1 over cos 2A is sec 2 plus sine over cos is tan, isn't it? Meaning sine 2A over cos 2A is tan 2A. Elementary identity, not elementary identities, but those are just trigonometric ratios, isn't it? So the reciprocal of cos is sec. So you can see you've even reached the end. You've reached what is required, sec 2A plus tan 2.